Hey, everybody. Hope you're having a happy Thursday. My name's Aaron LeBeau. I'm a developer advocate at Ditto. And today I want to talk to you about our next SDK release 4.12. What if your queries were leaner, your data easier to shape, and your tools worked across more platforms, all in a single release? That's what the Ditto SDK 4.12 delivers. It brings new DQL features like projections and aggregates, lets you create single field indexes right inside of DQL, and expands Flutter to support Linux and macOS. And of course, it comes with plenty of improvements and bug fixes too. One of the best ways I've seen in my career to see new features and actions is to upgrade an existing app. I took the Mflix movie app, the one I originally built to demo MongoDB connector, and I upgraded to SDK release 4.12. The upgrade not only made it easier to adopt new features, but it also boosted performance and gave me new ways to enhance the app. Let's take a look at the agenda for today. So, to start out with, let's do a quick introduction of Ditto, right? For those that maybe are new to Ditto or don't understand all the feature set, and then we're going to jump right into a bunch of cool features like projections, indexes, and sync status API. And then we'll kind of close it up with a summary. Okay. Now, before I start, let me really recap what Ditto does, right? So if we kind of look over here at this slide, Ditto is an edge native mobile database designed to keep mission critical operations running, even when the internet doesn't. Most databases rely entirely on the cloud servers and stable connections. But the reality is, networks go down, Wi Fi drops, remote locations lose signal. That's where Ditto stands apart. Ditto operates everywhere. Whether you're at the edge with devices like tablets, phones, or drones, at the enterprise edge, powering frontline workers, at the industrial edge with robots and factory systems, or even at the tactical edge, where decisions happen in disconnected or mission critical environments, Ditto keeps everything in sync. Your devices don't need the cloud to communicate. Ditto enables them to discover each other and share data directly using peer to peer mesh networking. So even if you're in airplane mode, deep in a rural job site, or facing a network outage in the field, your app continues to function, your data stays consistent, and your team stays productive. There are no single point of failures, no bottlenecks, just a resilient, self healing network that thrives wherever your operations take place. Now, the Ditto SDK version 4.12 ships with a lot of features, more than I can cover in a 20-minute talk. So I'll focus on a few highlights that stood out to me and show you how they helped me improve my demo app. You can check out the full source code on github.com. So let's go take a look at that real quick here. I'm going to bring up my web browser. Here I am. To get the source code, you can click on the code button right here, and you can pick whatever vehicle you like to get source code. Now, I already have the source code on my computer, so I'm going to go back to our DAC. Give me a second here. All right. Let's start with the very first feature, projections. In database terms, a projection is simply choosing which field you want to return in a query and instead of pulling back the entire document. This makes queries leaner, reduces the amount of data moving around, and can give your app a nice performance boost. Now, right away, I realized this could be a great fit for the movie app I built. Let's take a look at the schema that the default movie collection uses. Now, as a reminder, this comes from the sample dataset that MongoDB Atlas provides, so I can simply head over to their website to browse it. So I'm going to call my browser back up again here, and we'll take a look at that. I have a tab already open. So this is the movies collection that the demo app is built up based off of with the MongoDB connector that we have. If I look at the actual document itself, man, there's a lot of fields here. Underscore ID, which is the primary key. We got title, we got year, runtime, release. I'm scrolling. There's more that just keep coming. Boy, that's an awful lot of fields. But my app, I only need about 5 of them on the main screen. Let me show you the Flutter version of the movie app running on macOS, one of the new features in 4.12. So here I have the Flutter app here, and it may take a second to pull the data back, but here we go. It's up and running. you can see here on the main screen, I only have a few fields I'm showing. I have the movie poster picture, I've got the title, the year, the plot description, and some of them, if they have ratings, I have the ratings. Okay, well, if we look at this, my original query, let's take a look at that, right? And so we can try to compare, like, if I don't need all this information, how can I improve this, right? So let's go look here. So my original query here that I have, that basically returned everything back. But with projections, I can cut down the amount of data in memory when displaying the movie list. So, okay, on paper, this all makes sense. But the real question is, how much does this actually save? And the answer is quite a bit. And instead of just taking my word for it, let's run the queries, export the results, and compare the file sizes. That's one way we can try to show this off. Okay. So I'm going to use a tool that I have on my computer that I wrote that allows me to run queries and export data. So you can see here, I have the tool open and I have my first query in here, right? And it's that query we looked at earlier. It's just grabbing everything. So I'm going to go ahead and run that query here. And we'll see that we have results back and it's 2,330 records. I can click this button here to export, and I'm just going to export that as called query results. That sounds like it's good. I'm going to replace the file. I ran this earlier, part of my demo. I'm going to use my favorites link over here to go through and get the other. This is the projected version of it, okay, where I'm grabbing less fields, only the fields I need in the UI. Now let's run that and take a look at that also. We can see that we have the same result, 2,330. I'm going to export that, and I'm going to call that movie projection, right? I'm going to replace that one also. And then I'm going to use the Finder because I'm on a Mac to go to my downloads folder, and we could take a look at those. Now look at this. The movie's projection is 535 kilobytes in size, where the full results are 5.4 megabytes. Wow. That's a pretty dramatic difference between the two, right? That's actually pretty bonkers to me in my mind. So the key takeaway is this. Smaller objects in memory mean lower battery life usage and smoother scrolling in the app movie list because we don't have all that data. That's two big wins for almost no extra effort whatsoever. Very small change in our query, right? Now, I know what you might be thinking. There's an elephant in the room. If I don't keep the full movie in memory in the list, right? When I tap on it, I'm going to need to go fetch that full movie so it can draw the movie detail screen. And that's true. You do take a small performance hit when selecting the movie because I need to go back to the database and grab the movie by its movie ID, but that's the primary key. So technically speaking, that should be pretty fast. Let's look at this in action in the app. I'm going to show you the app running on a real iPhone 11, running the Swift UI version of the app instead. So I've got the app open over here, right? Here it is. I'm going to cancel this search. And I'm going to go through and tap on a movie, and we'll see how fast it loads on a real device. I've got a spinner. Let me go through and try a different movie. I'd like to see consistency. That tells me whether or not there's a problem. So there's a spinner there too. It wasn't bad, right? But it's a couple seconds, right? Somewhere between, I'd say, 500 milliseconds and a couple seconds to come back. And we look at this and say, well, okay, that seems like you went backwards, right? Because before, if you ran the app, it was pretty fast because I had the movie already in memory. Well, there's a reason why this is happening, okay? If we go look at it, I added new functionality. I added the comments and the ability to see the comments. So you can see here now, I pull the comments in. So I've added extra functionality, but it comes at a cost. You're seeing a loading spinner when the movie is selected, since it takes a moment to not only fetch the movie, but also now all the comments. So the question is, can I reduce the time it takes to pull the movie details and the comments? And the answer is yes. In 4.12, we've got a new feature to help out with that. Simple indexes on a single field. So what does that mean to the average mobile developer? It means you can create an index on just one field in the collection, which can really speed up queries. Let's take a look at the schema for the comments collection in MongoDB so we can see what field we should add a index to. So we're going to look over here and see that I have now the comments open, right? So this is the comments. You see here, right here on the collection. You see here, here's all the data, but here's the thing I want to point out. It's got a movie underscore ID. Well, that's the primary key of the movie. So if we go through and we can add an index to that, it should make things faster. So let's go back to my deck here and we'll see what I did. So see here, this is the syntax to add an index. It's pretty simple. You tell it to create an index if one doesn't already exist, and then you specify the collection name and the field you want to add to an index. So you can see here the collection name is comments and the field is movie ID. And this is just the name of the index that I want. So when I go look at my names of indexes, I know which ones are which. Now, I'm going to do something. I'm going to live on the edge. I'm going to update code right now on the stream. What could possibly go wrong? So I'm going to bring up my friend Xcode here because we've been demoing off the Swift UI version of the app, right? I happen to have some code here commented out that is basically the index for the comments. So I'm going to just take this and delete these 2 comments, and I'm going to do a new build and push it directly out to that iPhone 11. Now, a reminder that iPhone 11 is an old phone put out in 2019. It's the oldest phone that Apple still supports. So I know if it's going to be fast on there, it's going to be fast on all Apple devices. So let's take a look at this now running with it. So I'm going to take Xcode now that we know that this is working. I'm going to move it off the screen so we still have some screen real estate to see our presentation and stuff. And let's go look at that. Let's click on a movie and see what happens. I'm going to click on there. Whoa, that was near instant. That can't be right. Let's try a couple other movies and see what's going on here. Oh, we went from having a spinner to like literally the movies are loading like almost instantaneously. And it's pulling that in real time. So for example, this horse movie, it has to pull not only the movie details, but it's got 3 comments on it. All 3 of these comments also have to be pulled as part of that. Before adding the index, we saw that spinner come up telling us we're loading the movie in. And now we have it and it's like near instantaneous. Folks, here's the other thing. It's not just Swift. I noticed on slower Android devices, like older Android devices, the delay for the spinner could be anywhere between 1 and 3 seconds, depending on the device and the number of comments. Remember, the speed results can correlate back to the speed of the storage on the device. Older devices, Android phones, and if they're cheaper, usually have slower storage. So adding an index gives a clear performance boost, but it's not instant. On larger collections, an index takes some time to build. So for example, the comments collection has over 40,000 documents in it. So there's going to be a short delay before the index finishes building and you can really start seeing the benefits. So I've added this great feature, right, where I can go through and add comments and view those comments. But that also creates a challenge for me, right? How do I quickly test that adding comments actually works? And make sure I'm not actually introducing like this regression bug. So one of the simple solutions to look at is to basically make it so I can just go find movies that have comments on them. And then I can just go check them to make sure that the comments do show up and that they're syncing across my devices. Now that's where this new search bar comes in. Okay. Let's quickly look up a movie so we can see this thing running and make sure that it kind of happens, right? So here's the catch. Searching across an entire movie collection by a title could be a heavy hit in performance. And honestly, I'm a lazy developer. I don't want to type the full name every time. Some of these movie titles are pretty long. So I just like to type in part of the title and just basically get the movie, all the movies that match that. And that's where the like statement comes in. Let's take a look at that real quick here. If we look at the query I'm using, the like percent search term percent in my DQL statement, I expect this to be a performance killer. It has to pull every movie and look at a pattern in a string to see if it matches, collect all those movies, and then return it. Oh, and in the Swift UI version specifically, I decided not to add debounce logic, meaning the query runs on every keystroke in Swift UI. Now let's look at, on a real device, this iPhone 11, and see how fast this runs. And we know that it's going to be fast there. It's going to be fast on all the later models because they're got better storage and they're just newer phones, right? Faster processors. So I'm going to go in here and I'm going to start searching for some stuff. So I've got the movie here. I'm going to click on that here and I'm going to just start typing some stuff. We'll start with the horse movies because I know I added some comments in those. So I'm going to type in HOR, look at the movies change as keystrokes happen. It's happening in real time. It's searching through these 2,330 movies and looking through the titles and very quickly returning the results back. Near instantaneous. Let's try a different term like the word free. You can see as I'm typing, the movies are instantly changing. That is pretty neat, right? Let's just be honest. As a technical demo, that's pretty cool. Now, for a production app, I still highly recommend adding debug logic because it's going to reduce excessive disk IO and prevent unnecessary battery drain. But for a technical demo, the real-time updates are pretty fun to watch. In Flutter and React Native, I added debouncing because on older Android devices with slower storage, the performance suffered a lot when I'm constantly going through trying to re-execute queries. So now that I showed you indexes and I showed you how to create them and how they can help, how do you see them? How do you see what's going on with them? Well, the cool news is we have a full API for this. And if you just want to see the indexes on the system, Ditto exposes a special system indexes collection that just lists all the defined indexes on the device. Okay. And I created a screen for this. So I can show this off to you. I'm going to go to the Android version of the device this time, and this is running React Native. And it may be sleeping right now. Let me show you because this is Visor. This is like screen projection technology. So I click on something and then it kind of goes over and does it. So I have the physical device over here also, but it looks like Visor may be locked up here for a second. Let me see if I can get it to warm itself back up. If not, we'll go take a look at the macOS version of the app. Let me bring it over here, take a look at system. We'll see here under the index tab, I have the indexes on this particular device, right? And if I were to go look at the iPhone version, we can see here, the iPhone version, I added that comments index. So the comment index is showing on there. You can see there, the movie's title showing up here. And then the year is also moving. That's another index I just happened to add. And finally, my Visor woke up. So now I'm hoping that maybe it will wake up from React Native standpoint. And I can actually start to use it. Let's see here. So that's how we can see indexes and what the indexes I currently have on the devices. You can see that when I added that index, as we talked earlier about the comments, it instantly added this massive performance increase on the iPhone. So in summary, indexes can be used on a single field in a collection, and this can greatly reduce the time it takes to return data from the database. So let's talk about the sync status API. A keen eye would have noticed that when I went back to the app to show you the indexing, I also added another screen in the system tab. For this release, I wanted a real-time view of sync status across all my devices. I want to make sure that like sync is working when I have a bunch of different peer-to-peer devices running. So 4.12 introduced a new API for monitoring sync status. To build my display, I used a select statement, which powers a live sync status view. The DQL statement to render it is pretty basic. If we take a look at this, all I'm saying is just give me everything out of the system : data sync info, and I have an order by clause, right? And there's a simple reason for this. The sync session status will tell me, if I order those by that, it'll tell me all the connected devices. And those will always be at the top of the list, so I don't have to scroll because I'm always going to be concerned about the connected devices. And then the time received will just tell me the ones I have most recently updated. So that logically kind of makes sense. If I do my query based on that, I'm going to see all the devices connected at the top of the list, and I'm going to know the ones that I have recently connected because I'm going to order by that time, right? So let's show off the app running here, and we can take a look at that in action. So I'm going to go back to my React Native version, my Swift UI version, and my Flutter version running all here. All right, let's see here. Let's go to sync status here, sync status here, sync status here. So let's take a look here and see what's going on. And I also actually have it running on a separate app here, my Edge Studio app that I told you earlier. I also have it running here. You can see the sync status there, right? So if we look at sync status, what do we have here? Okay, we've got the peer devices connected. We have something called a commit ID. And then we have the last time it was updated. And we show the connected ones at the top, as you can see here, right? Well, notice that the commit ID for the Flutter version that's running on macOS is at 7,985. However, the commit ID over on iPhone here running the Swift UI is 4225. And then we have our last version over here, React Native, is at 12,286. Whoa. Okay. This seems kind of weird, right? That, we have devices with different commit IDs. So let me go through and see and I want to explain how commit IDs work. Okay. When updating items in a collection in the query results, for example, we'll always now return an array of mutated document IDs. What we added in 4.12 is we're also going to give you the commit ID. So let's do a demo of changing the data so we can see this in action and understand what is a commit ID and what does all this mean. So I've modified the Movies app to now return a commit ID when you update a movie. So we can go through and do that. So I'm going to go back to my friend Flutter here, and I'm going to go find the Minecraft movie, right? That's the first one listed here. And I happen to know that I don't have a time machine. This movie was not put out in 2027. It was put out this year. So I'm going to go and change the movie date back to 2025 and click the save button. We'll notice that when I click save, a little breadcrumb, they call it the snack bar, is going to show up with a message that gives me the commit ID, 8009. So now that I know the commit ID and the document ID, I can go back here, go back in my sync status, and look at this and wait a minute. My sync status is already at 8013, but my write was 8009. Is this a bug? No, it's not a bug. Okay. What's going on, Aaron? Why? What's really happening is that the sync is in progress with all the other peers it's connected to. And the database is processing CRDTs, conflict-free replicated data types, to resolve the changes I just made. A commit ID is at the database level for that given device, for this particular Flutter OS running on macOS, right? Think of it like a record of a transaction that's happened to that local database. Now, this means it's normal to have different commit IDs show in sync status on different devices. Furthermore, it's kind of, if you look at it and we think about this for a second, since all the devices are syncing at different times and they're calculating CRDTs, that means that they're all going to be constantly changing, right? Because we have to tell you what the sync status is. So when we look at these devices, we started with that movie update being at 8009, but we're already up to 8034. And you can see for most of these, they're up to date, minus this one peer that's 2 versions behind. That's also okay, right? Because technically speaking, each device is syncing at a different period of time. And so because of the fact that we can't guarantee that all the syncs are going to run with all the peers at once, then the commit IDs, they could be off a little bit. They could be off a couple different versions. And that's perfectly normal, okay? What you really want to be concerned about is that they're relatively around the same number per device. So in my Flutter version over here, it's really important that they stay somewhere in this 8043, 8041. That's okay. If we go over here, and these are all in the 4,290 some range, that's okay. And over on the React Native version, they're all around 2,300 or 12,358, and that's okay. And they may be 1 or 2 numbers off. That's perfectly fine. That's exactly how sync should be working. That's healthy. Now, finally, you may notice that on an initial sync of a new device, you see the value -1 as a commit ID. Now, that's not a bug either. It's just trying to figure out what it needs to do to get sync up to date with all the other peers given CRDTs and other things that are involved in the sync process. So when you usually see a -1, that just means that the peer is starting out first time. It may talk to a new peer and it's like, ooh, I need to calculate a CRDT. I need to make sure I value myself out and then figure out like, what do I need to do to get up to latest and greatest with this peer? And that's just a calculation thing. So it's okay if you see -1 for a short period of time when you connect to a new peer. Obviously, over a long period of time, if it stayed at -1, then you have some kind of connection problem. We'd have to go through and start diagnosing, right? So, in summary, the new Sync API can give you information about the status of your connected peers. You can just go through and see this, and it's awesome for troubleshooting and making sure that your sync status is working. You can drop things like Bluetooth, make sure that peer-to-peer Wi-Fi is still working, all those kind of things. It's going to be really great for developers tuning their applications in different situations. Folks, that's all the time I'm going to have today to talk about 4.12. There are so many other great things and features in that release that you should check out the release notes on our docs site. So let me go through that real quick here. We go take a look at the release notes. They're always can be found under Build with SDK at docs.ditto.live. And if you scroll under reference, there'll always be a release notes section. I just happen to have the Swift version open, right? If we look here, you can see that there's aggregate functions now. So the ability to do counts, that's pretty cool. And it turns out in my app, I was showing off earlier how I get these counts in the query. is via that aggregate function. So I already added that to this app 412, and I have this cool thing of doing paging because I have all the new functions that aggregate functions do. So that's a really cool feature that you should probably go check out. There's plenty of other things going on here, like Flutter. We now have Linux support, which is great. There's a lot of bug fixes and stuff. So, and it's by language. So if you're not using Swift, that's fine. We got Kotlin. We've got all the languages you love to write apps in. So you can go check those release notes out. Now, let me go back to my deck here. Now that we have this, I do want to open up real quick to see if there's any questions that we may have. So let me go through here and check out and see what's going on. Check out the community. I'll give a few seconds here to see what's going on. I know it's kind of early in the morning, and that's okay if everybody's still just trying to get ready there right before your lunchtime if you're over here on the East Coast or in Central Time. All right. I don't see a lot of people asking questions. So, oh, wait. Andrew, good job explaining to a non-database expert like me. Hey, you're welcome, Andrew. Anytime. It's really kind of interesting that we've been doing this for a while now. And what I really want to do is find out what people want to learn. What would you like to see me talk about next, right? I would love to get some feedback on that. I would like to continue talking and teaching and show you guys stuff. So if you have some ideas of like things that you want me to talk about, maybe it's like a deep dive into CRDTs or something like that, leave a comment. I would love to hear that. And I will take that very seriously for future talks. Now, I'm going to let you guys go, let you guys get back to your days. One, please take care of each other. Remember, as developers and technologists, we're all in this together. Okay. So take care. Have a great day. And I'll see you on the next one. See y'all.